GivEnergy's high voltage stackable battery range. This has got some serious energy storage potential and some serious performance potential. It's capable of future-proofing your home or small business. Today I'm going to be breaking down everything you need to know about this top performing piece of kit. Let's go. First of all, what does a stackable battery storage that's high voltage mean? I think a lot of people in their mind think, well, I've just got normal voltage in my home, I can't possibly use this where I am. That's where you're wrong. When it comes to high voltage stackable, what we mean by that is the voltage of the DC packs, essentially the storage batteries that the energy is stored within. We have this battery stack that's here. Now this is broken down into individual battery packs. Each battery pack is 3.4 kilowatt hours. Now, you need a minimum of 3 battery packs for this particular piece of kit to start working and operating. So you have a minimum storage capacity of 10.2 kilowatt hours. Now, for each stack, you can have up to 6 battery packs, so 6 3.4 kilowatt hour batteries. So this gives you a limit per stack of 20.4 kilowatt hours. Now, for each inverter, you can have up to a maximum of 4 stacks. Pretty much and essentially that's a theoretical limit of just over 81 kilowatt hours worth of battery storage per inverter. That's pretty crazy if you ask me. So these inverters come in 4 different sizes. 2 for single phase and another 2 for 3 phase. So depending on which incoming supply you've got, they will make one for both scenarios, both of which use the same stackable battery storage system. Give you some serious juice if you need it. So first of all, let me zoom in a little bit on the single phase model. Now, for anybody that does have a 3-phase connection, there are a couple of 3-phase options, 11 and 20 kilowatts. All that really means is you can have more solar panels. A lot of the facts and information around the single phase that I'm going to zoom in on are largely very similar and interchangeable. So the single phase inverter comes in 2 main models, an 8 kilowatt and a 10 kilowatt version. It doesn't really affect the charge and discharge of battery unless you're getting right to the top end, because the 10 kilowatt hybrid can charge and discharge at 10 kilowatts. Something to note about the high voltage single phase and 3-phase versions is the fact that the number of battery stacks dictates the amount of charge and discharge that you can get from your overall system. So the limit of a single phase inverter would either be 8 or 10 kilowatts. Now in both scenarios, the battery stack doesn't affect the solar input that would happen for that. So if you have 10 kilowatts worth of solar generating, the number of battery packs won't limit the amount of solar you can convert using that inverter. However, what can be limited is by the number of battery stacks you have. So if you have 3 battery stacks, you'll essentially get 6.5 kilowatts rate worth of charge and discharge. Bearing in mind, at this point, if you've got 3 battery packs, you've got 10.2 kilowatt hours worth of storage. So if you've got 3 battery packs, you could effectively fill those battery packs in little under 2 hours. Now, every time you add a battery pack, roughly speaking, you get just over 2 kilowatt hours worth of extra charge and discharge ability. So for 4 battery packs, you get 8.75 kilowatts charge and discharge. Now the point to note here is, if you select an 8 kilowatt inverter, your limit is 8 kilowatts, so you can't get the 8.75. But if you pick a 10 kilowatt inverter, you get that full 8.75. If you go for 5 battery packs, so this is 5 3.4 kilowatt hour battery packs, your charge and discharge rate would increase to 11.1 kilowatts. Again, the limiting factor at this point would be a 10 kilowatt inverter. So if you have 5 battery packs, your limit of discharge is 10 kilowatts, but you do have 5 3.4 kilowatt hour battery packs. I appreciate that that's a little bit confusing, but I wanted to take the time to explain. Now, if you've got 6 packs, which is the most that you can put on 1 stack, bear in mind you can have 4 stacks, 80 kilowatt hours worth of limit, then your theoretical rate of charge and discharge increases to a whopping 13.1. So if you go for the 3-phase range, effectively, and you went for the 20 kilowatt 3-phase, you would get that full capability. So I wanted to break down some installation considerations that you need to have for these high voltage stackable batteries. There is a set of guidance that's there for installers. It's called PAS 63100, and this basically gives the installers the idea of where it's best to mount it. However, there are a few additional considerations you'd want to give, mainly around the weight of these batteries. Now, as you can imagine, a normal battery storage, if I'm dealing with the low voltage battery range, a battery might be 50 kilos. Heavy, but not particularly heavy. Whereas we're dealing with, if you have 6 batteries, maybe as much as a couple of 100 kilos, multiple battery stacks, more and more weight. So you won't want to put it somewhere like an attic, for example. I think that would be a poor place to install this. You probably technically could with some different requirements, smoke alarms, fireboards, etc. But I just wouldn't recommend it. Instead, I would be looking at an area like a garage, for example. If you don't have a garage, the back of your house. Now, these would be very difficult to try and steal. They have a series of screws that hold it all together. They're very heavy. If you took a battery stack off and put it on another stack, it wouldn't work because they're individually registered to you as a person, and GivEnergy would essentially have to transfer the commission. They're going to know about it effectively if it was reported as stolen. So they're very difficult to try and steal, but I would always think that doesn't stop someone from trying. So I would always put it towards the rear of my home. I would keep it away from any entrances or exits to my home, just somewhere tucked neatly out of the way, under a little canopy. One thing to note is the fact that these can go outside. From a performance perspective, it's always better to try and get them in a garage because the temperature will be slightly higher. So on those cold days, they will perform that little bit better. Now, from a height and depth perspective, I'm 6 foot tall. And if I stand with my back up against the wall, shoulder and height wise, it's roughly about the same size. That gives you an idea of your installation area that you would need to free up. Now, from a depth perspective, the stackable batteries, I mean, they don't take as much wall space because if you put multiple batteries on a wall, you don't need as much wall space, but they are a bit deeper. Think A3 piece of paper size when you bob it on. It's a little bit like a photocopier size is a fair way of putting it across. But the good thing is you can just get over 20 kilowatt hours worth of battery storage in a really small, compact space. So it really is good from that perspective in comparison to other manufacturers. Now, I commonly get asked how long one of these systems takes to install. GivEnergy have done a belting job of making it really quick for installers. For you as end users, you want to pay as little engineer time as possible and as little money as possible also for the product whilst getting maximum quality. GivEnergy have made these stackable, so essentially you get the bottom of them and you just click one into the next one. They're really quick to be able to put together and install. There is some work to do on commissioning for the initial batteries, however when we're adding additional module after module, that process is nice and quick. So if you started off with 10.2 kilowatt hours, which is the minimum number of stacks, and at a later date you think, I want a little bit more charge and discharge rate on performance, I want a few extra kilowatt hours worth of storage, they're very straightforward in 3.4 kilowatt hour modules. Plonk another one on, redo the security grub screws, commission them in, and with a couple of hours you've expanded an additional round of battery storage on your system. So a typical length of time it would take to install a hybrid inverter. The hybrid inverter itself, with all the wiring, connections, isolators, cutting it out, putting stuffing glands in, I would say around a day. And the battery storage packs, only a couple of hours. They're really quick. We normally say with testing and inspecting on a straightforward install, every install's different cable lengths can be different of course as well, typically speaking around a day and a half from start to finish to install a hybrid inverter and stackable batteries, which by way of the industry standard is very, very quick indeed. Later on in this video, I'm going to be breaking down the cost and what my personal opinion is of the GivEnergy storage system. Another fact for you, 96% of people that are watching this content now have not subscribed. Subscribing means we can bring the best possible quality content to you as the end users for this industry, different products, different scenarios. Please do take the time to like and subscribe. It means a massive amount. Now let's break down monitoring and control systems and how intelligent these inverters truly are. GivEnergy, from the ground up, have created their own mobile phone app. Now, one of the things I quite like about GivEnergy is the fact that they're not white labelled. They manufacture their own software, and that's built here in Stoke in the UK. So you have, I think it's 30 or 40 software developers now based in Stoke that constantly work on this app. It's very simple, very intuitive. And what this means is you can see what you're generating by way of energy, you can see what the last week's done, the last month's done, you can see what you're doing in real time, so you can tailor your energy usage. What you can also do is have smart integrations that enable you to be able to charge cheap nighttime electricity. Say if you're on an EV car charging rate, for example, and you can charge that energy into the battery, or you can discharge the energy out to the grid and get paid a premium for it. GivEnergy have also created something called an open API. An open API sounds a little bit complicated. But as I mentioned in our low voltage battery storage video, I'll put a link in the description below so you can have a watch of that. I talked a little bit more about the API and how it all works and operates. Think of it a little bit like the App Store for your mobile phone. There are a lot of third-party developers that have effectively developed software so you can intuitively control these inverters. So third-party applications, and soon to be coming to the GivEnergy mobile phone app through their development team, is the ability to look at weather forecasting. So if you've got a sunny day ahead, you can look at how much energy generation is going to generate there. You can work out how that affects your energy usage. So we can look at an algorithm to look at how much you use, how much energy is going to be generated, how much it needs to buy in, and get that energy mix perfect to give you maximum return on your investment. One of the key integrations that GivEnergy have done very, very well is talking and communicating with energy suppliers like Octopus. So Octopus have their Flux Intelligent tariff, which dynamically controls your inverter on your behalf. So when it's cheapest on the national grid, your batteries will charge. When it's most expensive on the grid, your batteries can discharge, or it can bypass the batteries altogether to get you maximum return on investment. Another little note actually is the online GivEnergy portal. So many people just don't realise this is a thing. So on your mobile phone app, you can have quite limited controls. To be honest with you, day to day, this is going to be ample for what you need. But if you're one of those people that's quite a bit techie like me and you want to go further, the GivEnergy online portal gives you loads of information about what your inverter's doing, which is brilliant to see. We can also remotely log into your portal with your permission, of course. So when it comes to diagnostics, the old way would be we'd send an engineer out straight away, they'd have to diagnose it, and they go away and find parts or whatever's needed. The modern way of doing this, which GivEnergy have really enveloped in, is the ability for engineers like ourselves, when you're going, I've just noticed something a bit strange with my system, we can log in and we can make those settings and changes on your behalf, talk you through what those mean, how they work, how they operate, and give you that education and that empowerment so you really understand what's happening with your inverter. If there is a fault, it can be remote diagnosed. We can turn up with the right parts if they're needed, and just get on with getting it right back online in a really simple, straightforward way. Talking of getting the inverters back online, if you ever had a problem, and they get very few with these, they're a very mature piece of technology because the high voltage stackable batteries have been out for quite some time now. They come with a 12-year warranty, and on these battery storage packs, that's unlimited cycles. So effectively, they will keep charging and discharging for a solid 12 years. The battery packs are 100% depth of discharge as well, so you can really get the most out of those battery storage packs. GivEnergy are based in Stoke in the UK, just in the northwest. In the event that you did have a problem, and very few of you will have these, you can speak with someone based here in the United Kingdom and get that diagnosis done locally. They have engineers that are capable of going out to installations if it's needed as well. So it's really slick and very straightforward. Talking of support, you want to look for the right installer for you. You need to be asking a good couple of questions regarding your GivEnergy system if you decide to go for this. You want to make sure your engineer truly knows about the portal, how to access it, because there's really simple things that they can do, like pushing a software update and doing that remotely. It's so easy for them to do if they know what they're doing. So do double check the fact that the installer you're thinking of picking, like we're platinum installers, they're registered with GivEnergy, they are a suitable installer, and ask them a couple of questions so they truly know what they're doing. So you're probably thinking in your mind, is this kit maybe a bit big for me? It sounds like real high performance stuff. If you're 6,000 kilowatt hours per year in your family household usage or more, exclude EV car charging from that equation, because anyone that's got an EV will automatically be over that, but you would always charge your EV at night. So if you're 6,000 kilowatt hours a year or more, then I would be highly recommending the high voltage stackable range. If you're 6,000 kilowatt hours or less, watch the video we've done on the low voltage battery range, because that's probably a little bit more where you're going to be looking from a performance perspective. Now, when it comes to high voltage stackable batteries, these are really scalable. So if you're just at the start of that energy usage, 6,000 kilowatt hours, but you know you're going to increase that usage, say in a couple of years' time, you'll be getting a heat pump, then these are really scalable. So you could start out, if you're on a single phase supply with a 10 kilowatt inverter, start with 10.2 kilowatt hours worth of batteries, but then in a couple of years' time when you buy a heat pump, you can just add a couple of stacks on, the charge and discharge rate will increase, and your overall battery capacity will increase too. Theoretically, this system takes you to the limit pretty much of where a single phase supply that come into your home can take you to. You can't put much more on it, otherwise you'd simply overload it. And when it comes to the 3-phase supply, for any domestic property, again, 20 kilowatts worth of inverter, which is the biggest 3-phase inverter they make in the high voltage stackable range, that's seriously big for a domestic property. Well, you'd even do your small scale commercial, to be honest with you. So you've really got that expandability from almost the usage of where you are now, 6,000 kilowatt hours a year or more, all the way up to the theoretical limit, essentially, of your incoming supply cable. So in the GivEnergy range, if you've got a heat pump, or if you're thinking of getting a heat pump, this would be one of my top recommendations for an actual product. Why? Look at tariffs like Octopus Cozy, which are on a heat pump you may well have already. This gives you a very limited time window to charge your batteries up. Now, you need a big enough inverter to grab enough energy from the grid, store it, and then when it gets expensive again in the next time window, its energy can then take itself and push it out to your home. We want the biggest inverter possible to be able to facilitate that with alongside your tariff, which is why I would recommend this as a product. With a bigger inverter, like this hybrid inverter with the stackable kit that we've got here, there may well be more requirements upon yourself as the end user and your engineers when it comes to the national grid. If you've got a 3.68 kilowatt inverter or below, that's notified under something called G98. Fit and notify when you tell the grid. When you go above 3.68, you get a G99. Now, in advance of installing these inverters, your installer will have to notify the national grid. We're in the Northwest now, and this is Electricity Northwest. Other people may well be Scottish Power. There are a few different network authorities. When you put the application in, I would imagine your installer is going to apply for the theoretical maximum discharge possible. Let's use the single phase 10 kilowatt hybrid inverter as my example here. So what we're saying is we want to send up to 10 kilowatts out to the grid. The national grid may well say there's too many people with solar nearby you. Our supply transformer is too old. They do this as part of a network feasibility study. Essentially, is it feasible for you to connect? Now, typically speaking, they'll give you at least 3.68 kilowatts onto the grid. But don't worry too much about this, because locally your inverter can still supply to your home at the maximum discharge rate of your actual inverter. So you've got a 10 kilowatt inverter, it can discharge its full amount. Then it's for your installer to essentially try and negotiate with the national grid to get the maximum rate of discharge out to the grid. If they set your limit at, say, 6 kilowatts, it's very easy and straightforward for your engineer in the settings to say, we're going to do 10 kilowatts charge and discharge locally, but we can only do 6 kilowatts discharge out to the grid. So when your installer puts a G99 application in, if the DNO restricts that application, it's a thing called a G100. These inverters are smart enough to have a G100 export limit device built in so that they can meet the requirements of the national grid. Essentially, they can tailor the export to suit the national grid, and internally and locally in your home, you still get the benefit of all that stored energy that's sat in within your batteries or the local generation if you can use it in real time. Another thing that this hybrid inverter has is a thing called an EPS output, emergency power supply. Now, if it's not set up like this, your inverter will turn off in the event that the power goes off. If it is set up with the EPS enabled, normally you need a fuse board, an earth rod, and a few other little bits as well, like maybe a changeover switch, then effectively, in the event that the power goes down, you can have a couple of options, one of which is an automatic changeover switch. Essentially, if the power goes out, automatically the inverter will change over and essentially you will get a whole home backup, or you can have a manual changeover switch. The power goes out, you turn the switch and the inverter is capable of discharging. Now, if you're on a three-phase system and you're lucky enough to have something like a swimming pool or a big load, you would want a manual changeover switch because you'd essentially need to turn your swimming pool pumps off in the event of a whole house cutout, and then you would want a manual changeover. If your loads are a lot lower, so below the theoretical floor limit of your inverter, then an automatic changeover switch would do. One of the main reasons you'll buy a hybrid inverter is for the number of solar panels that you can install. Now, at this point, if you've got a slightly higher usage, you may have a bigger roof. Don't just think that these hybrid inverters are completely suitable for just those people that want more and more solar panels. Theoretically speaking, you could have, say, 8 solar panels on one of these hybrid inverters. You don't need a great deal. So for some of those households that don't have a big roof, but have high performance demand and just need lots of charge and discharge and lots of battery capacity, this will also be suitable. But for those with a bigger roof, where the low voltage GivEnergy range can't process enough of that solar generation, this is where the high voltage hybrid inverter comes in. So in the single phase, as I've mentioned, we have an 8 kilowatt and a 10 kilowatt option. They have a maximum amount of input of solar of 15 kilowatts, so 15,000 watts worth of input. This is done over 2 maximum power point trackers, but you can have up to 4 inputs. So if you've got really big arrays on a roof, this will be able to cope just fine. In the 3-phase options, we have an 11 and a 20 kilowatt inverter, and they can take up to 30 kilowatts worth of solar. Now, in panels, what on earth is that? So if you think each solar panel would be around 440, 450 watts per panel, you're somewhere in the region of around 30 to 35 solar panels on the single phase range, and on your 3-phase range, you're somewhere in the region of 60 to 70 solar panels. Each solar panel has a different voltage and current, so it's really important that your engineer checks and works that out for the theoretical limit. But what we do know is, for a domestic property, you can load them up. Let me break down the idea of cost. This is a little bit more complicated. As a system increases in size, there are far more parts to give consideration towards. So if I'm fitting an 8 kilowatt inverter, it's going to come with slightly different parts to a 10 kilowatt hybrid high voltage inverter. More panels, more cost. Let me cut through the mustard a little bit and take this with a pinch of salt, please, from a pricing perspective. I'd always recommend a bespoke pricing. But if you have 16 panels on a Marley style roof, so that's a concrete tile, if you had a 10.4 kilowatt battery stack and a 10 kilowatt hybrid inverter, I would anticipate the cost for that to be somewhere between £12,500 and about £14,000 fully fitted. If you've got a slate roof, if you want more battery stacks, each 3.4 kilowatt hour battery stack will be somewhere in the region, depending on where you are in the UK, of £1,400 to £1,500 fully fitted. They don't take a great deal of time to actually install, so the installers, unless they're hoodwinking, you don't need a massive margin on them because they'll make a little bit on the trade discount that they get from the actual manufacturers. They'll charge you a little bit for installation, a bit for the installer as well, and they say they're quite quick to install, so £1,400 to £1,500 every time you want to add another 3.4 kilowatt hours. There is a bit of cost involved in the initial setup of the battery stacks, but when you start to want to add extra modules on, it's quite cost effective, particularly when you're looking at a system that you may well have to future-proof because you're thinking of buying a heat pump or you think your demands may well increase. So yeah, 12.5 to 14, 16 panels, 10 kilowatt hybrid inverter and 10.4 kilowatt hours worth of battery stacks. But get your installer to do a bespoke quote for you because it can get a little bit more complicated when you're looking at this size of home. Now I'm going to break down my own opinion of both the single and three-phase stackable high voltage hybrid inverter. We're going to start with technology. Now, as a technology, I really like the GivEnergy range in general. As I mentioned previously, we've got integrations with smart tariffs like Flux Intelligent, the ability to access the open API, other software providers being able to control your inverter. I also like the fact that with the actual technology, your data's stored inside of the UK, that they've got tech developers here in Stoke, in the northwest of the UK, that can add tweaks and changes to the app. Now, on the low voltage range, I rated technology an 8. I'm going to go a little bit higher for the high voltage stackable battery range, to a 9, and I'll explain why. Because within this technology, they've created the ability to add extra batteries on in a really straightforward way. At the low voltage, you can add extra batteries, but it's the fact that you do it in 3.4 kilowatt hours at a time, and it's much more straightforward from an engineer's perspective. And for you as an end user, you don't need to be so capital heavy. So I'm going to give technology a solid 9. Performance-wise, I suppose this depends on how many batteries that you purchase. As I mentioned previously in the video, the more batteries you buy, the 3.4 kilowatt hour increments, the more the performance increases. But on a theoretical basis, we've now purchased 6 of these battery packs and we've got a full stack of batteries. There's not much more you can really get out of a single phase domestic supply. And even on the 3-phase inverters, there's not really much you can do from a domestic home perspective. You've not much more you can really give to a home. So I'd struggle to downrate that in any way, shape or form, if I'm completely honest. You can theoretically get the maximum performance that your home is capable of. So I can't really give it anything else other than a 10. It performs where it needs to perform. It's got good performance. When it comes to warranty, GivEnergy gives the battery storage and inverter a 12-year warranty. And on the battery banks, that's unlimited numbers of cycles. So you can charge and discharge this as many times as you need to do it. So I'd give that a 10 as well. One of the things I want to just quickly cap off, however, is the service at GivEnergy. If you go and read the Trustpilot reviews on GivEnergy, you'll notice towards the back end of last year, there was a bit of a dip. And this was because GivEnergy as a brand grew exponentially. I know this because we've been on the journey with them. We're platinum installers now. We've done 400 plus worth of their GivEnergy systems. We know them inside out and round about. One thing we noticed, as the number of installations grew, the service was struggling. So what GivEnergy took the decision to do was completely close the customer phone lines whilst they upgraded, trained new team members and got new software integrated for that service for the consumers and for the engineers as well. They came out with a new installer app, and for installers they've now created online e-learning. They did loads of stuff whilst they were closed down. With warranty, there may well be a couple of customers that were frustrated, so I just wanted to take the time to cap that off, because you might think, what a load of nonsense. I tried to call them in December and couldn't get through. You're right, 100% so. But I've got to judge them on the here and now. Our experience over the last few weeks since they've had these integrations upgraded, I think is significantly better. They've invested in AI to try and help end users. They've created videos and video content and tutorials. So it was just something I really wanted to cap off there, because there will be a couple of frustrated customers over that Christmas period. And I really think that GivEnergy have turned a leaf in that respect and really improved their aftercare. Next one, affordability. Price per kilowatt hour, the high voltage stackable battery storage system is more expensive. If you're using less than 6,000 kilowatt hours a year, my recommendation would be to strongly be looking at the low voltage battery range. Unless of course you're adopting a technology like heat pumps, electric heating, then you might want to flip back onto this for future proofing. But when it comes to affordability, it is more expensive. If you're using more energy through putting more kilowatt hours through these batteries, then you'll find your return on investment will be at a suitable level, 6 to 8 years typically speaking. But if you're not using enough throughput, if I only use 2,000 kilowatt hours a year and you bought one of these, you'll be waiting a long time to get your money back. And I really just wanted you to be aware of that. Everyone wants the best performing item, but it's really important you look at return on investment. So for affordability, I suppose it's scenario specific, but I'd probably actually give that a 7.5 because they could make them cheaper. You can't get high performance and affordable. Now this brings me on to my next one. This is my personal favourite, coolness. They're pretty good, but I've got to be truthful here. They're not the coolest item on the shelf, but if they're putting them in a garage and they're there for a performance item, I really think like GivEnergy in terms of coolness as a brand behind the scenes are really cool. Like they do loads of cool stuff like integrations and stuff, as I've mentioned. But the products, they've rounded the corners, they've made them look pretty good. I think they could do a little bit of improvement in terms of like the sleekness of the aesthetics. But to be honest with you, you're buying this to cut your bills down. You're buying this because it's a good quality mid-range product rather than buying really expensive stuff that looks cool, but you might struggle to get return on investment. Coolness, they're not too uncool, but I wouldn't say they're the coolest thing in the world. I'd give that a solid 8. This gives us a total score of 8.9. I'm gonna round it up to 9 out of 10. If you're a high performance household, I would strongly be invested in the high voltage. If you're a lower performance household, so 6,000 kilowatt hours and below, I'd be looking at the low voltage range because you're just going to get that better return on investment. Thank you.